the previous video, we have shown how to define the material properties for rubber and the steel cords. In this video, we'll show how the contract between them are. So let us first turn off this one. So why the contract is important? As we know, the bottom stack is L1 and the upper stack is L2. So the contract between them is bonded, or we can say glued. So we have to define the contact in between them, and also the contact between the top surface and the upper face of the scatter rubber plate isolator is not bonded, it's totally on friction. So we have to define the friction as well as for the bottom surface also. So how do we define it? First we have to go to the contact. So first we have to define the contact bodies. There are 4 bodies: the L1, L2, the top surface and the bottom surface. So let's just go here. So let's go to contact, then new, first mesh deformable. So let us define L1, select add elements, sets, and L1. Okay, same L2. Okay, so you can see there are 2 sets. This is under the contact bodies. So this is the first contact bodies L1 and this is the second contact bodies L2. Okay, then we have to define the top surface. They are not going to sustain any loads, so you have to define it as a geometric. So go here, new, geometric. So this is the top. So right now this one should be moved in the x-axis. So this one should be load control. So the control type should be load. So which one is the load? We are going to apply the load here in this node that we have defined in the first video. So you have to choose this one. So select control node and this one. So according to this node, the surface will be moved. Okay, so this, click OK and choose the surface, this one, right click. Okay, so the same goes for the bottom part. So click new, geometric, right bottom, and this one will be fixed because the bottom surface will not be moved, the upper surface will be moved in the experimental setup. That's why the upper surface is load controlled and the bottom surface will be position based. So click here, control type should be position, so it will be fixed in the Z0 position. So click OK and then select the surface, select add surface, click this one, the bottom one, right click OK. So we can show the contact bodies here, like turn on this one and you can see this is the lower contact body, this one is the L1, this is a L2, this is our top surface, this is our bottom surface. You can change the color here you can edit it, this one, or you can choose edit here, or you can choose any color. It's your choice. Okay, right now we have defined our contact bodies, but we haven't defined our contact in between them. So go here, contact tables, click new, it will generate a contact table. Sorry, maybe I previously clicked a contact body. So this is our contact body, click here, this is our contact body. So click touching. By default it's all touch. Touch means friction, but it's not friction, somehow glued, so we have to define. So if you expand it, this one a little bit, you can see mesh, there is some contact interactions. This means how they are going to interact. So the L1 and L2 are defined as mesh deformable. So the mesh deformable part has a glue contact. So we have to define that interaction in the mesh deformable versus the mesh deformable as a glue contact. So click here, change the name. We can choose glued, or we can say glue. Change this one, contact type glued, then click OK. So the mesh deformable, it means this one and this one, L1 and L2, and their bonding will be. And the mesh deformable versus geometric, it means the upper surface of STRP and the top surface of and their bonding, their interaction. So the interaction between top and the upper surface of STRP will be friction based. So we have to define that friction. So go here, interact. This one is touch, or you can say friction, anything. Okay, let's type friction. Okay, so we have to turn on this one, then it's touching, and you have to add the friction coefficient here. So click here, friction. The friction coefficient is 0.8. If you go to Google, you can see the friction coefficient between steel and rubber is 0.8. That's why it's defined as 0.8. Click OK and OK. If we go to the contact table again, you can see this is our element matrix. So we can turn off this one, we don't need it, because L1 and L1, this one means L1 and L1, we don't need it, and also L2 and L2, this one is also we don't need it. So you can inactive it, so click remove inactive. Okay, so you can see, look, the L1 is glued with 2, which has 2 L2. So the contact between L1 and L2 is glued, and the contact between L1 and 3 and 4 is touch. 3 and 4 means top and bottom, and the contact between same goes for the L2. You can choose, you can view here also. If you don't understand the matrix, you can go here and go to entry list. You can also say, look at here. Okay, the contact between L1 and L2. Okay, so L1 and L2 is glue. L1 and top is friction, is okay. L1 and bottom is also friction. L2 and top is friction. L2 and bottom is friction. You can say L1 and top is not touching. Look, L1 is in the bottom and top is the upper. As we have defined, the L1 to L2 is glued, and the L2 to top is friction. We can say L1 and top is also friction. So that's why L1 to bottom top is friction. Okay, so this is our contact body. So this is all okay. So we can go to here. This is okay. Right now we have to embed. We have defined some carcass layer, but you can see the carcass layer is overlapping the rubber material. In the real case, if you see this one, this figure, you can see the steel cord layer is embedded into the rubber layers. It's a vulcanization process. So we have to insert the carcass layer into the rubber layer. So how can we do it? We can go to links. Here is a inserts. So write insert and new. So we have to insert all our bell layers. So first carcass. The host entity is the rubber, and the carcass will be embedded. So the host entity is rubber. So add, set, click rubber. Okay, and the embedded entity is carcass. So click sets, carcass, click OK. Same, add this all for other belt. So belt 1, rubber, belt 1. So we have embedded all our carcass, belt 1, belt 2, belt 3, belt 4 in our rubber materials. So in the next video, we'll discuss about the loadings. Till then, see you in the next video.